Action.
Perfect, sir, perfect.
All right, today we're doing integration by parts, 7D, so there's only 3 examples. So it's perhaps a tiny bit easier than what we were doing yesterday. And this is the formula we're going to be using, so we have a formula this time. But the trick is we do need to assign which one's going to be U and which one's going to be V dash. And so the hint that we give you, U should be easy to differentiate and V dash should be easy to integrate. So that's the sort of thing there. And when they're both easy to differentiate and integrate, then you may just have to check. One way will work, the other way won't. All right, but there's only 2 possible ways it can be presented. All right, so I've got the proof for this formula written above. So have a read of that in a moment. You can understand where it comes from. But what we're doing is we want to integrate this, okay, x cos x, it's a product. So what we're going to do is we're going to assign U and V dash to some of these. All right, so if we go U is x and U dash will be 1, and we've got V dash is cos of x, so what would V have to have been? Sine of x. All right. So U is x, I've assigned U to x. V dash is cos of x, so that's my V dash, and then I've got the U dash and I've got the V. I've got all the components we need. This is what it evaluates to. So we're going to have the integral of x cos x is equal to, all right, what do we have? We have U times V. That's going to be x times sine x plus the integral of U dash V. So plus the integral of 1 times cos x.
Is this minus or formula?
Oh, sorry, thank you. Yep, minus. So that's going to be x sine of x, take sine of x, plus c.
Isn't it cos of x?
The integral of cos of x is positive sine of x.
The integral's sine of x. It's V.
U dash v, sorry. Sine of x, so yeah, you're correct. Here is a U dash v, 1 times sine of x. So then we have integral of sine of x is negative cos of x. So we have plus cos of x. Okay. All right, over here, here's where we can apply the hint. All right. So the hint says U should be easy to differentiate and V dash should be easy to integrate. So if we've got these 2 parts, one's U, one's V, we can't actually integrate ln of x. All right, we're not told how to do that, which means we're going to have U as ln of x, because that's what we can differentiate, and V dash as x to the 4. All right, so we've got U with the sign V dash, and U dash will be 1 on x, and V will be x to the 5 on 5. Okay, so then the integral of x to the 4 ln x is going to be U times V. So we have 1 on 5 x to the 5 ln of x. Take away the integral of U dash V. 1 on x times x to the 5 on 5. Alright, then let's slowly evaluate that one. This is going to be x to the 4 on top of 5. And then we can form it. Okay, so in that circumstance, we knew where we had to assign U and V dash because we can't integrate ln of x. All right, but if you don't know, there's only 2 possible ways, right? So try both. If one of them doesn't work, obviously you have to do it the other way. All right, we have e to the x sine of x. So this one's going to be a little bit tricky because we have to do it twice. So we're going to assign u as, so we start with u, yep, e to the x, and b dash as sine of x. U dash will be e to the x, and b will be integral of sine x to the negative cos. So we'll make the statement with that information. The integral of e to the x sine of x is going to be u times b. So that's negative e to the x cos x. Take away the integral of u dash v. So e to the x negative cos of x. Alright. Now, if we've done this, now we can simplify that, right? Negative, negative will become positive. Now, if we've done this, we're going to notice a problem, which is we can't actually integrate that. Okay, so what we need to do is we need to apply integration by parts again, just to this part. Okay, we're going to apply integration by parts just to this part. All right, so let's communicate that. Apply integration by parts to the integral of e to the x cos of x. All right, again, we'll let u be e to the x, and b dash is cos of x. Integral of cos is sine. Alright, so I'm going to communicate up here, I think. So I can just go, that's what we're trying to find. Here's what it's going to be. It's going to be uv, so that is e to the x sine x. Take away the integral of u dash v. Just wait. There's a cool trick. E to the x sine x.
Oh, you're going to substitute.
Yeah, something a little bit like that. Okay, so let's talk about what I just did then. So I've applied integration by parts. We've got uv, that's e to the x sine x, and then take away u dash v, the integral of e to the x sine x. Okay, so that's what this part is. The integral of this part is this statement here. So now let's re-put this back in here. Okay, and let's assess the situation. So I'm going to just rewrite this line up with this substitution for this term. What have we got? We've got the integral of e to the x sine x with regards to the x is equal to, so this part now, minus e to the x cos x plus, alright, and here's the substitution. Okay, here's what I have. What is it? It's e to the x sine x. Take the integral of e to the x sine x. All right. Who's got an idea looking at this? It's a cool trick. Perfect. Yep. This we can add it to both sides. All right, because that and that are the same term. So if I add the integral of e to the x sine x with regards to x to both sides, it's going to cancel here, and we'll have 2 lots of it over here. And remember, that's like a really cool example. You can do anything as long as you do it to both sides. All right, so that's some cool information there. Minus e to the x cos x plus e to the x sine x, and then we'll just divide both sides by 2 and chuck a plus c on the end. Alright, so a little bit tricky that one, but that's the law, isn't it? Alright, so let's give this exercise a go. Formula to follow. Let's try it out.